Hello, ladies and gentlemen. Today we're going to be examining angle relationships in triangles, and in particular we're going to be examining three different theorems that are associated with triangles and their angle measures. The first one is something that you've probably heard several times before, that all of the angles of a triangle need to add up to 180. No matter what triangle you have, as long as it's drawn on a flat surface, it's going to add up to 180. So as an example here, suppose we have a triangle. Right? We have a triangle, we have an angle of 12, an angle 62, an angle of 40, missing angle in red, missing angle in blue, missing angle in green. We don't know what those three angles are. If we'd like to calculate those angles, that's as simple as tracing out a triangle. Suppose we trace out this right side triangle. We know that triangles always add up to 180 degrees. So I could say something like, well, this one already has a 62 and a 40. That means that this last one has to be 180, subtract the 62 and the 40 from it. I know 62 and a 40 makes 104. 180 minus a 104 is going to give us a 90. Or excuse me, 102 is going to give us a 78 degree angle. So that means that angle right here has to be 78 degrees. Now, what about the other angles? Well, if we keep on using this theorem, overall this angle up top here, I'm going to draw this in yellow briefly, hopefully that shows up. 12 plus the 78 makes a 90. That means that this whole angle up top is 90. And so if we look at this entire triangle now, that I'm sketching out in yellow, the entire thing, it has a 90 degree and a 40 degree showing. As of right now, we can completely ignore the 62 because it's not part of the bigger triangle. It's not one of the three angles of the bigger triangle. And we could go ahead and find this angle by saying 180, subtract the 90 degree, subtract the 40 degree. That means that that angle, once we do that subtraction, has to be a 50 degree or have to be a 50 degree angle. Now, as far as that last angle goes, we want this blue angle. We can do a couple of things. Either we can say, well, it's forming a straight line right here with 62. It needs to add up to 62 to make 180. Add up with 62 to make 180. Or alternatively, it needs to add up with 50 and 12 to make 180 on this left side triangle. But 50 and 12 is also a 62. That is not a coincidence. That is, in fact, another theorem we'll talk about in just a moment. In any case, we're going to go ahead and just do the 180, subtract the 62, and that's going to give us a 118 degrees. 118 degrees for that last missing angle. Now this is pretty cool because we were only given three angles in this triangle, and we were able to find three additional angles. It's a pretty powerful concept. Now what do we do if we have x's? Well, pretty much the same thing. If we want to solve for x in this triangle here, we know they all add up to 180, right? So I'm just going to go ahead and say, maybe I'll draw this in green. I'm going to go ahead and say the 70 angle plus the x plus 20 angle plus the 2x angle all adds up to 180 degrees together. So then we could combine some like terms. The x's go to 3x. The numbers are going to go together to make 90. It's going to add up to 180. I'm going to go ahead and subtract a 90 from both sides. All right, subtract a 90 from both sides, so that cancels out. We're left with a 3x on the one side. 180 minus 90 is equal to a 90 on the other side. And then we can go ahead and just divide both sides by 3. We're really just asking ourselves, 3 times something is 90. Well, that x then, let's get it back, that x then would have to be 30. All right. That x would have to be 30. We can check our work by plugging in. I know this triangle is not drawn to scale because if we plug in here, it looks like it turns into a 50. And this 2x, 2 times 30, would turn into a 60. So I probably should actually flip these two angles in my examples in the future just because the 50 and the 60 look like they should be flipped anyways. If we add up all these angles together, the 50 plus the 60 makes 110, plus 70 makes 180. All of our angles add to 180. There we go. So, I mentioned before, there is a reason, and we were looking at this a moment ago, there is a reason that when we got our 50 degrees on this previous example, that this angle plus that angle is equal to the outside angle on the outside of the triangle. This is something called the exterior angle theorem. All right, exterior angle theorem. And the exterior angle theorem essentially says that if we have two interior angles, two what are called remote interior angles, so angle 1 and angle 2, let's say, angle 1 and angle 2 are always going to add up to the exterior, and remember from previous chapters, the exterior is the outside angle. They're going to add up to the exterior. All right, so the measure of the exterior angle of a triangle is equal to the sum of the measures of the interiors. So we could say, in algebra speak, the measure of angle 4 on the outside here is equal to angle 1 added up to angle 2. Now, why is that the case? I can show that with some algebra here. If we look at these two angles, 3 and 4, you'll notice that they form a straight line together, right? Form a straight line together, so I could say measure of angle 3 is equal to measure, or plus measure of angle 4 adds up to 180. All right, it's one equation I could write. I see that we have 3 different angles on the inside, 1, 2, and 3, that need to add up to 180. So measure of angle 3 plus measure of angle 2 plus the measure of angle 1 all adds up to 180 as well. All right. Well, in both of these equations, measure of angle 3 plus some stuff, all right, measure of angle 3 plus some stuff is equal to 180. Measure of angle 3 plus some stuff is equal to 180. This stuff, if you're doing some substitution, have to be equal to each other. So the measure of angle 4 needs to be 1 and 2 added up together. How can we use this in an equation? And feel free to pause the video and try these problems out before I announce the answers. Well, if we want to find this missing angle up top here, let's say, we know that D and E, angles D and E, need to add up to this other angle. So I'm going to call this angle X for now. I could say that 62 plus the X needs to add up to 142. All right. Once I subtract 62 on both sides, I'm going to get that X needs to be 80 degrees. All right. Needs to be an 80-degree angle. And we found a missing angle. We can always check our work by making sure that that's a true statement. I know these two need to add up to 180, so this one has to be a 38. All angles of a triangle need to add up to 180. We've got an 80 plus a 62 is 142, plus a 38 makes 180. We check out. We can do the same thing when we have some x's in an equation as well. I want to solve for x here to get my measure of angle B, which has x's in it, gradually. We know that the two angles need to add up to 180 together, or excuse me, the two interior angles need to add up to make the exterior angle. All right, so I'm going to say that 15 plus the 2x plus 3 needs to add up to the 5x minus 60. All right, I'll get some like terms combined. At the same time, just to save some space, I'm going to subtract 2x on both sides. So that's going to leave me with, on the left side, 18 is equal to. On the right side, we are left with 3 x's now, minus 60. Now I am running out of space on my screen here. Next step, though, I'm going to need to add 60 to both sides. All right, so I'm just going to continue this problem on, let's say, up here a little bit. On the left side, 18 plus 60 is 78. On the right side, I just have that 3x left because the 60 is canceled out. Divide both sides by 3. That should not be a hard thing to do. I know 3 goes into 60 20 times, and 3 goes into 18 6 times, so this should end up being an x is equal to a 26. once you divide both sides by 3. And we can plug in. We can plug in here. We could say 2 times the 26 plus the 3. I know 2 times 26 is going to be a 52 plus the 3 is going to be a grand total of 55. We'd say this angle right here, 55 degrees, that is the measure of angle B. Now we can check our work by plugging in here as well. If you plug in 6 times 26 minus the 60, you're going to get a 70 degrees, which makes sense because the 15 plus the 55 needs to add up to make that 70. It works out. Nicely done. Last theorem, and this is kind of the oh duh, that seems obvious theorem, is called the third angles theorem. And the third angles theorem says that if two angles match, so for example, L and R are congruent to each other. We know that because they each have one single tick mark. And S and angle M are congruent to each other. They each have a single tick mark. That means that the last two angles, so angle N and angle T, need to match up as well. So if two angles already match up, the third angles need to match up as well. We can say that N and T are congruent to one another then. Now how can we use this? Suppose we have two triangles, they're overlapping a little bit. I notice that two of their angles match already. G and H match, they're congruent. I know that F and I match, they are congruent. What does that mean? Well, that means that K and J have to match. Now I am drawing 3 notches on each of these angles just because they're not the same size as either the 1 or 2 notch angles. They're 3 notches, they're a different size. But they are congruent to each other. So I could go ahead and write that out. 4y squared is equal to 6y, I'm going to leave some space for a squared, minus a 40. 6y squared minus 40. I'm going to treat the y squareds just as I would treat any just simple y's. I'm just going to subtract a 6y squared from both sides. Alright. That's going to leave me with a negative 2y squared on the one side. And the other side we just have negative 40 left. Alright. We divide both sides by a negative 2. That's going to leave us with y squared is equal to a 20. Now you might remember from algebra, if we want to get rid of a squared, you square root. What keeps square trees from moving? Square roots do, of course. So if you would like to square root this, that's cool. You're going to get some pretty funky decimal over here. The 20 is going to give you some pretty funky decimal. I don't want a funky decimal for this problem, so instead, rather than doing the square root, I'm going to realize that both of my equations have y squareds anyways. And I'm just going to plug in the y squared anyways. In this right one, we're going to have 4 times y squared, which is 20. 4 times 20 is an 80. And on the other side, we have 6 times 20, which is 120, minus 40 is also an 80. Both those angles match up. They're equal to each other. We must have done this problem correctly. Assignment for tonight, there should be a worksheet from chapter 4.2 on Moodle. If you have any questions, as always, email me. Have a delightful day.